Hello, my intrepid coders. We're here in this video talking about the unsung heroes, the brave soldiers who run application tasks in the background, web workers. So we are jumping off a little video series where I'm just exploring like weird little and fun little optimizations in vanilla JavaScript code. We are coming off of debouncing, throttling, requestAnimationFrame, and then now we're here in web workers. Now this is not a playlist or series. I will have all the links down below if you want to watch those previous videos. I'm just kind of exploring some fun topics that I think are intermediate in skill level, but I'm trying to keep them as simple as possible for beginners to learn from them. And again, at the end of the day, this is all about adding tools to your tool belt. And this is a really good one to have when you finally get to that point where you have something that may be completely unoptimized or very calculation intensive and you realize it's slowing down or blocking your website. So remember, this entire series was spawned from a student's question about debouncing that led me down this crazy rabbit hole of discussion and video content I'm making. So they are a community member. They pay $25 a month for access to our front end and back end courses, which combined together make up our full stack program. I have built and made a standalone React course that goes from zero to hero, talking about state management libraries, beta React APIs, all that fun kind of stuff. And I'm currently in the works on a TypeScript and database standalone course as well. These are meant to expand what our full stack curriculum already offers. So if you want these lectures, challenging labs, support in Discord, and custom content like this, then consider joining up and finding a link down below. Otherwise, let's get going here. Just like my other videos, if you want to just sit back and listen and internalize and learn this stuff, then by all means do so. If you want the same HTML and style sheet code and the blank app.js and to code along with it, then pause the video and look in the description down below for a link to a Codepen. The Codepen in this case is a little bit more complex than before. It will have the HTML and CSS and all the JavaScript code if you want to just copy it all along and poke through it. It has two versions that I have commented with my caps lock key on, so make sure you read the comments about what you need to set up, because I had to do a separate way to make sure that the web worker worked in Codepen. Since I don't have the ability to add multiple JavaScript files in Codepen, I had to figure out a different way to do it via something called a blob and a create object URL. So you'll see that in the Codepen code, but you'll also see the comments about the final code and where to put it in this walkthrough. So either way, let's get going. We have a simple HTML with 3 buttons, one that says say hello, one called calculate with worker, or rather identified calculate with worker, one with calculate without worker with some text that's appropriate as well. My style sheet is also quite, it just applies a typical Vaporwave theme I have on a lot of my websites, or these demos rather. As you can see, this beautiful Vaporwave theme right here. I have 3 buttons. Clearly this one's going to say hello. Clearly these are going to be calculating something with the Fibonacci sequence. I was trying to think of a way to block the main thread, which is what web workers are going to aim to solve. And the easiest way I could think to do that was to make a recursive solution using the Fibonacci sequence and plugging in like 40 or 45, which will sometimes take up to 10 to 15 seconds on my machine to calculate, and that might be even longer on your machine. So play with the Fibonacci input value and see how long you can block your own machine from running. It's actually kind of funny. Okay, so web workers, the whole purpose we're here, right? So to define them, web workers are a way to run JavaScript code concurrently in the background, right? Separate from the main execution thread of a web application. It allows for intensive calculations or computations or tasks, whatever you want to call them, without blocking the main thread, ensuring that your user interface remains responsive. So basically, we talk about JavaScript being single-threaded, meaning there's one thread where everything executes on, and that is it. But we do have the ability to call upon web workers to move things off of the main thread and run concurrently, like I said, in the background of our main thread. So think of this like if you've ever worked in a busy kitchen, whether it's in a restaurant or anything like that, you probably already kind of know how this goes because you have a head chef, which is kind of like our main JavaScript thread. They're responsible for sometimes expoing, sometimes like assembling the dishes, making them look good and all that kind of fun stuff, and putting things together. But they have a team of sous chefs, which are going to be our web workers. So we have our head chef as the main thread, sous chefs are our web workers, right? And the sous chefs will handle various tasks like chopping vegetables, filing, parboiling, all that kind of fun stuff. And they all work concurrently, ensuring that the main chef isn't overwhelmed and can continue to assemble and plate his dishes smoothly and call for service. So similarly, in a web environment, while the main thread handles UI and interactions and things like that, web workers can take care of a background task, making sure that our user's experience isn't interrupted. And unlike the requestAnimationFrame video, this one will have a very, very obvious visual output when it is correctly working, right? So web workers were introduced as a part of the HTML5 specification somewhere back in 2009, 2010. I looked it up before this video and didn't write it down like a fool. I'm not editing. I'm not going to go and look it up, but somewhere around there. Just like late 2000s, early 2010s, somewhere around there, HTML5 specification, right? They came about because of a growing need for improving performance and responsiveness in web applications. So as web pages grew in complexity, limitations of JavaScript were quickly being found, so web workers emerged as the solution to offload tasks and keep things running smoothly, right? So over the years, they become more and more widespread, and they should be something you put in your toolkit. So it's not something you should just use right out the gates on your applications. It's one of those things where when you have a performance issue, meaning a expensive calculation that is blocking the website from continuing to run, you offload it to a web worker, and that's the if-else statement you're going to run in your mind about when to use these, right? So like I said, they're great for performance-intensive tasks, data processing, or even polling, which is a concept that also I can make a video on from debouncing and throttling. It's kind of polling, should have been probably one right after those two right there. But yeah, if you want to do some polling, a great way to do it is via a web worker, right? So like I said, JavaScript is traditionally single-threaded, right? It means executes code line by line from top to bottom. Web workers allow us to then run something concurrently alongside the main thread. And unlike the main thread, which, we have discussed this in previous videos, or if you have any JavaScript experience, we know that the main thread typically refers to itself as the global window object, meaning it is where JavaScript code is running on the window. This is where we can put some global variables if we want to. And we have access to things in the window, like our position of our mouse cursor, its inner height, its inner width, and stuff like that. But there is no window object in a web worker because it's going to be a separate thread from our main thread. So we're actually going to be using the designation called self, which references the web worker's own self context as an object. So self will refer to our web worker as itself, saying, I'm a web worker and I have these things available because I'm not a window. And on top of that, while we don't have to keep them in separate files, it is a good practice to keep them separated, right? We have isolation and organization on our side if we take this. So it's considered best practice. It isolates the worker logic away from the main application code, and it aids in that clarity and maintainability of keeping code in smaller chunks and in separate files. The way they will communicate, because there is no DOM that the web worker can talk to, we can't manipulate it or rely on event bubbling and propagation and things like that. So to communicate, the main thread and the worker will send messages back and forth. And this is going to be done via, functions, messages, and event objects and things like that. So we can actually start and stop web workers either from within themselves or from within our main thread, almost like a cancel button in our main thread and maybe an error terminate button or a terminate event over in our web worker code. So like I said, if you have something that's blocking your website's UI and user experience, offload it to a web worker, and that's going to be kind of like your way to go. So enough talking, let's actually code something out. Now, unlike my other videos in this small little optimization series, I've never had to do this before, but for understanding and just getting y'all some good practice and not overcomplicating it for the newbies, we're going to make another file today, one called Fibonacci worker.js. I'm going to go ahead and write this Fibonacci function, and I could just move this to a third file and script source them to make sure it's available. I'm just going to copy and paste it between both out of laziness. So we're going to have a function called calculate Fibonacci that will take a value n, and it will calculate the value of the nth position of the Fibonacci sequence, like run 3, 5, 1, no, 1, 2, 1, 2, 3, 2, 3, 5. 1, yeah, 1, 2, 3, 5. Blah, 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 blah. All right, so we're going to calculate the nth position of the Fibonacci sequence. And the cheesiest way to do that is with recursion. It's also not it's a fun solution, but not the best solution. So what we're going to do is say if it's less than or equal to 1, just return n because that's its value. Otherwise, let's return a call to calculate Fibonacci. Call to calculate Fibonacci, where this one is the previous 2 positions back, and this is the previous position to our current value. And this recursive solution does indeed find the Fibonacci sequence value of n, and the higher that n is, the longer this calculation is going to take. So what we're going to be doing here in our Fibonacci worker, and like I said, I'm going to copy and paste this between my app.js and here because I'll need it in both places. And I know there's ways we can share it between the both, but let's just keep this simple. It's already going to get complicated enough as it is. So just like in other instances, the code itself is, in my other videos, the code itself is not that extraordinarily complicated, but I will break down what's happening so you can understand. So, like I said, Fibonacci worker.js is not our main thread. It does not have access to the DOM. There is no event propagation. This is just going to be referencing a web worker, which we're going to say, hey, I am my own individual web worker, and I wish to add an event listener to myself that does the following. When I receive a message, here is what I want to do. So remember, there is no DOM to traverse or communicate with, so our web workers will be sending and receiving messages back to our main thread, aka our app.js. So our event worker, our web worker, gets an event that when it receives the message will do the following. Run this function, capture the event, because that event is how we can access any message that's sent into the web worker. So basically, we're going to be sending in what position of the Fibonacci sequence I want to calculate, and we're going to call that n, right? So we're going to say const n equals event.data. That is how we're going to pull that value off of our event. It's going to be passed in under a property called data. I'm going to put it into a variable called n that represents what this web worker should be calculating. That way we can make this dynamic. Then clearly we're going to get some kind of result from our Fibonacci calculation of our value of n. And when that is done, I have to say, hey, self, the web worker, I need you to send a message back to the main thread, because remember, that is how they communicate. And we do that via a method called, surprise, post message. And if I can learn to type here, we're going to send the result. We're going to send the result back up to the main thread, right? Because remember, this is kind of like running concurrently in the background. And guess what? That is as complex as this little guy needs to be. So it receives a message. The message will contain some data that will be, hey, this is the position of the Fibonacci sequence. We're going to calculate, put that in a variable for convenience. Then we're going to call that function, which could take 5 to 10 seconds, depending on what position I ask it to do. It's going to get the result, and then it's going to send that message back to the main thread. So this is our web worker. This whole thing's purpose is to offload this expensive, time-consuming calculation of the Fibonacci sequence with a recursive solution from the main thread. So the reason I have this in 2 places is, remember, I have 2 different buttons, one that will use a web worker and one that will not. So we're going to have both accounted for. So first things first, let's go ahead and grab our button called, we'll do query selector. I think it was called camel cased say hello. Called say hello. And surprise, surprise, it's going to be a click listener that's going to run a very simple function. This function is going to simply log hello there. And that's it. That's going to be its sole purpose. And let's make sure I haven't broken anything so far. Yeah, say hello, hello there, nothing to it, right, folks? Okay. Then, down below, we're going to run another query selector, and my ID this time is, let's do the one that does not have a web worker. So we're going to grab calculate ID, calculate without worker. I'm going to select that right there. I'm going to add an event listener to it of type click. And if I can learn to type today, man, the tooltips just get in the way these days. There we go. I think it's because of my zoom level on my mouse cursor is during these demos. Okay, so now that I have that event listener coded out, we are going to do exactly what the web worker is meant to offload, aka we're going to get a result from my calculate Fibonacci sequence. Let's do like 43 or 44. I think that on my machine, that ends up being like a little around 5 seconds or more. I think 45 is where the 10-second plus mark tends to hit. We're going to see here in just a moment. And this is going to console log our result when it is done. So here's what I mean by when a web worker is very evidently needed. Remember, I can click say hello and it's going to log say hello as many times as I click that button. But look what happens when I block the main thread because it's busy calculating a large value or something like that. And I'm going to try and click this button and then go click say hello. So watch this. Calculate, click, click, click. Nothing's happening. My mouse cursor is stuck. What's going on here? I can't click anything else. The whole thing is frozen. And it took 7 full seconds. That feels so long on camera. Anyone that doesn't do any kind of recording, 7 seconds of dead air is like agony, and I don't like having to do a lot of editing to my videos, especially if I make mistakes, as I feel like they're good learning opportunities and kind of humanizing. But man, it's funny how like dead air like that can feel like forever. But anyway, there is the calculation of the Fibonacci sequence, and there is how long it took, 7,000 milliseconds, so about 7 seconds, and we can see that I was spam clicking the hello there button while it was calculating. So it was basically entirely frozen, which is not a great user experience, while it did this calculation. So this is a great example of, okay, well, clearly the main thread is getting blocked by this calculation. The user can't interact with the website. Everything looks like it's frozen. We got to fix this. And then you, the new newbie / now intermediate developer knowledge student of mine, YouTuber, whatever, coder, programmer, I have words. You now have a tool to go, aha, I know, let me pull a web worker out of my tool belt and it's time to solve. So let's go ahead and select that final button. We're going to say, hey, query selector, I need you to run an ID selector here. We're going to say ID calculate with worker is what I called it. Who said I didn't? Add event listener. It'll be a click listener as usual, where it's going to run a function that runs the following code. Now, we need to create a new web worker. So you'll notice here in our code, remember the Codepen is a little bit different, but it has comments about what's different about it. Notice here that I only have my app.js script source. This is because the web worker, remember, is not working on the main thread in the browser. It's not involved in that at all. So by practice, we keep it isolated in its own file, even though we don't need to. It's very common to do so. We also don't script source it here because it kind of indicates that it's not acting as just a main thread JavaScript file with some shared variables or functions or something. It is meant to be its own isolated thing, right? It is a web worker that is separate from the main thread. But we have to use some kind of declaration for our code to know that. And we're going to do that with the following. Const worker, this is a variable. You could just as easily call it pizza. I don't care what you call it. I'm going to call it worker. And mute. Get cats on the brain. I don't think my cats are in the room right now. They'll be here soon enough, though, if I call them. They know I'm talking about them, so someone's going to wander in at some point. We're going to make a new web worker, right? And then we're going to pass in the name of the file, which I'm going to typo here, Fibonacci worker.js. Oh, and it needs to be a string. Joke's on y'all. There we go. Fibonacci worker.js, Fibonacci worker.js. All right, now we've got it working, pun intended. So now we have to say, hey, if I receive a message from the worker, what do I do? So I'm going to say, hey, worker, if you get a message posted from the web worker back here, I need you to run the following event. I need you to grab this event, and I need you to console log the event data. So again, just like we passed in the N via event data to the web worker, right? We're going to grab out from this post message the event data. This result will be the e.data that we are console logging down here. So now I've coded my worker what it needs to do if it receives a message. So now it's time to send a message to the web worker. So remember, this is what to do when the worker gets a message, or rather when the main thread gets a message from the worker. Now the main thread is going to send a message to the worker to do some work. So I'm going to say, hey, worker, I'm going to send you a message, and I want you to calculate the 40, what did I do up here? I did 44, let's be consistent. We're going to do the 44th position, which took about 7 seconds of blocking the web page. So this gets sent into the web worker. It grabs it on this variable, or it receives a message, which means this function runs. It grabs the variable that I passed in from the post message from the main thread. It calculates the result, and then it sends a message back up to the main thread. The main thread has this function here that says, hey, when a message comes in, grab it and log the data. So that's what's happening here, right? So receive message from web worker, and this is send message to web worker. Okay, just so we have it straight in our heads. I know it's kind of confusing for newbies to understand some of these more intermediate concepts, even if the code's right in front of you. I was there once, not like 6 years ago, so I remember what it's like. And I teach all the time, so I know exactly the kind of questions and trouble y'all run into regularly. All right, so that's what's going on, and that is all it is to this code, right? So let's take a look over yonder, right? So like I said, say hello, no tricks up my sleeve. Say hello works just fine. Now remember, when I clicked on without web worker, everything froze for about 7 seconds of long dead air. But how about calculate Fibonacci with web worker? Click. Look at that. I can keep console logging my say hello button, and it's totally fine. Like my website is working exactly as it should. And as we can see there, I've been talking and circling my mouse and clicking on the button, and it's been logging all that stuff. And voila, my web worker has sent back its response, and my website was functioning like nothing was keeping it hanging. So we have now learned a really cool new skill. So something else that you might sometimes see on, like Reddit threads or Stack Overflow comment sections or blogs or other tutorials you might have found this from. A lot of the time you'll see, because we're doing a event listener, you might see this third argument here to your event listeners called face. Just kidding. False. This is, event listeners typically have in the DOM things called event bubbling and capturing, but because there's no DOM tree we're traversing, there is no DOM here. Remember, the web worker is not running in the browser. There's no event capturing of any kind. A lot of the times you will specify false to these event listeners on web workers because it's a good practice to do so. As you saw, it worked fine without it, but it's a good thing to know how to write there because it specifies it. It makes it clear what this thing's purpose is. There's no event bubbling happening here because there is no DOM tree to traverse and bubble up through, right? So, just for consistency and clarity, the false is not just like an assumed default value, but a lot of the time specified. So if you ever see that, that's what's going on there. And yeah, there isn't a whole lot else I think I need to tell y'all. I talked about post message is how, again, this whole messaging system works. On message is the event handler in our main thread to receive messages. Post message is how the main thread can communicate with the web worker, and how the web worker can communicate back to the main thread. Event data allows us to get a value sent into the web worker or a value coming out of the web worker when the message is sent. Other things to know. We can cancel the worker with worker.terminate. So maybe a button that cancels this, or a separate scrolling or page changing event could terminate the worker. So if it's taking too long and the user has decided to navigate away and the calculation is no longer needed, we can terminate the worker from the main thread via worker.terminate, right? Now, the corollary to that over yonder would be our, I think, on error. So I can say, or rather it'll be self.close. Yeah, self, and again, we can just do just self right here. Yeah, self.close is a way where we can close the web worker from inside the web worker itself. So that's how we would close it there. Okay. And then if we needed to do error handling, I believe we do it over here where we do an on error and we would pass it a function that, would grab the error and do some kind of console log alert message, modal or something, should something occur and there's an error and we want to do some error handling. So with those methods and event handlers, you can effectively manage communication between a web worker and your main thread now, and you now have this tool in your tool belt, right? So yeah. That's really about it. That's the magic of web workers decoded. So hopefully, whether y'all been learning to make animations buttery smooth from requestAnimationFrame, leveraging web workers for hefty computations, learning about throttling and debouncing functions on repeated events and stuff like that, there you go. Remember, if you have interest in learning from me, hanging out in Discord, having a ton of courses at your fingertips, and feel free to check out the link in the description down below for our community membership. Do all the YouTube things, like, comment, subscribe, and yeah, keep those neurons firing, keep that code going, and keep learning, because that's also what I do every day. Later.